I'll stop it.
Yeah, that's so much better.
Hi everybody, welcome to this week's walkthrough. This week we're going to be going over simple harmonic motion, the study of actions and motions that repeat for objects. This week you'll see that my wife has joined us. Again, this is Jordan. Welcome back to the show. So simple harmonic motion is really just about looking at how things move back and forth. A word that you'll hear frequently that's not written up here is called oscillation. And most periodic motion is some form of oscillation. But before we get into the details of this, let's talk about this week's pre-lab activity. In this week's pre-lab, what you want to do is go into the good old Firefox app, look for the acceleration without G, click on that as usual. We have the three axes. Remember, it's been a couple weeks since we've done this. We have the x-axis, which goes this way, y, z coming out, and you're going to take data. In order to take the data, we want to go with a periodic motion. So you click Start Collecting Data. You see it kind of goes in as usual. Now you go in circles. You do this. You keep the phone in the same orientation the whole time. After you've run several of these, you click on pause. You see you've got very clear oscillatory motion on two of the axes. One of the axes is not showing quite as strong because we tried to keep it not oscillating in that direction. And click in, zoom in as we've done before, go over a 2-second period at least, and make sure that you're filling the space to the best of your ability. You can click on pick a point, pick data. You can pick points along the axis to find different places that correspond to different periods. You click out, and remember you want to keep your selected. Click OK. Do the same thing. We're on a 9 to 11 time frame. This one's a bit larger than the settings. And now, again, you can see the data points. If you wanted to choose those, click OK. And now you can see these two are 90 degrees. This is 0 when this is at negative value. This is at a minimum value when this is around at 0. These are clearly offset. So you want to make sure that you confirm that data when you do your measurements. In today's lab, you may recognize an instrument that we used before, the Passport. Basically just a motion sensor. It gives off ultrasonic sounds at a rapid pace that we'll set into the lab. Make sure that you set it to about 50 hertz in order to have a good set of data to work with. But you can gimbal it and modify it until it's facing the direction that you want it to do. And obviously it sets on a surface. When you arrive at lab, you'll find your station already set up. It's going to have a spring with a hanger attached to it. It'll have a pendulum, which will be a heavy lead ball. And for today's activity, I want to have fun, so we're going to play with my friend, the smiley face. In addition to the spring, you're going to have a set of masses with you. You don't have to assume that the masses that you have are the only ones you have available. There's plenty of masses around the room that you can mix and match to try and find what you're looking for. But what you're going to do is first measure the spring constant of the spring. Every spring has its own measure of stiffness. We call it the spring constant. It's indicated by the letter K in what's called Hooke's law. And the first thing that you'll want to do is measure the spring constant of your spring. To do that, you start out by measuring. You'll hold a meter stick close to it, and you'll add a mass. Hold the meter stick close to it, add a mass. You'll notice that it descends under the influence of gravity. You'll measure the position once it's stopped oscillating. You'll measure mass once it's stopped oscillating. You record that into Excel. Then you add another mass. Record the mass and the displacement. Again, record in Excel. Do this 5 or 6 times until you've got a collection of data points that you can use to create a graph, the slope of which will be your spring constant. Once you have the spring constant, the next thing that you do once you've got the spring constant is to choose a period of oscillation that will apply to both of these oscillators. To do that, you make a guess. You have a range within to work, somewhere between 0.8 seconds and about 1.5 seconds. That's pretty much the limit you're going to have with the equipment that we have available. you make a guess on that period. You'll calculate the mass that you need in order to oscillate at that period. You will then look at your masses and you'll find the mass that's closest to your calculations. You may or may not find it, but you want to go to the closest mass that you can. Once you find that mass, you'll use that mass as your set mass. That mass is now set for this oscillator, and you use that set mass to calculate with this spring constant the period of oscillation for the spring. Then you take that period of oscillation, this will be your set period of oscillation, and you're going to use that to also set the period of oscillation for your pendulum. You then apply the set period to the period for a pendulum and calculate the length that the pendulum needs to be. Now it's very important that you pay attention in your setup. What is the length going to be? Is the length just the length of the string? In fact, it's the length between the center of mass and the point at which it oscillates up here. So up here. So you'll want to take care to measure that very carefully. Once you've got your set period established, your set masses established, your set length established, it's time to take the data. To do the data, first thing you want to do is make the measurement of the oscillation of your spring. So you take the passport, set it directly underneath, shift it into position so it's facing straight upward and is directly underneath the oscillating spring. You may have to play with this a few times to get the alignment right so that the signal is nice and smooth, but then you simply set the spring into oscillation. Be careful, don't overstretch the spring. We're not trying to change the spring constant. We just wanted to have a measurable set of data. You just click start. You'll hear the popping sound or the clicking sound, whatever it sounds like to you. That indicates that it's taking data. You monitor the data on the screen, make sure that it comes out nice, smooth, clean data. And then once you've got at least 5 periods of clean data, you can hit stop. After you've collected the data for the spring oscillation, now it's time to move on to the pendulum oscillation. To do that, you want to situate your passport such a way that it's facing directly onto your pendulum. For your experiment, you'll be using this heavy mass at the end of the pendulum, but for today and for fun, we're going to be using a smiley face. You situate your passport so that it can see this face, set it in motion so it's oscillating towards us. Remember that this is an approximation, so we don't want to go on a very wide swing. Once you've begun your pendulum swing, you lift up the backboard to help block out any background sounds. Make sure you don't go completely vertical because bouncing back sounds can interfere with this and create sort of an echo. So you have it kind of tilted outwardly. Once you've got that all situated, you click start and collect your data. Again, you double check to make sure that the data is coming back in a smooth oscillating pattern. Get about 5 periods of motion, maybe a few more just so you have some data to work with, and then you can hit stop. And now it's time to go and take a look at the Pasco setup. Okay, so by now we expect that you're pretty well familiar with working in Capstone. I want to show you a quick trick so that you can set up your graphs in a kind of nice, easy layout pattern. We click on Hardware Setup, and when it comes up, you should be able to get the moving man. Once you've got that, you come down to the bottom into your record palette, and you'll see that your motion sensor you want to change that to about 50 Hertz so that you can get a good set of data that's nice and smooth and a little bit easier to extract calculations from. And then you go and you grab a graph, you bring it onto the workspace. Now you notice that there's some gray spots around the workspace that you can go to. We're going to go to the very top one. It's going to place the first graph right there. We'll zoom that up a little bit because we're going to need to make room for 3 graphs. Then we come over and we'll grab a second graph and drag it into the unused space. Again, we want to go ahead and go into the upper bit. It seems like it's scrunched up, so let's stretch it out. We're going to have 3 using the same axis, so there's no reason we can't cover up that single axis. It'll automatically say time anyways. Then we come up and grab the third one, bring it into the workspace, and you notice this time it's going to fill the space. We could go up here, but it just crunches it down. So let's go to the open space here in the center. So let's go to the center spot and fill the entire remaining space with the third graph that we need. Grab it by the little dot in the middle and bring it up. And now you see your graphs are all about the same height. If you want to play with it, you just click on the graph that you want to shrink up a bit or stretch a bit. Give it that adjustment that you're looking for. And once you're satisfied with your layout, you want to keep the numbers visible. Go ahead and change go ahead and select your measurement. Remember that you want to keep them in a kind of a natural flow of information, so you have position, velocity, and acceleration. So we can either set this as position, velocity, acceleration, or acceleration, position, or acceleration, velocity, and then position. I'm going to choose position for the first one, velocity or speed for the second one, and then acceleration for the third one. And as I said before, these should all have the same axis, so you can just go ahead and click elsewhere on your space and then begin your data collection. That does it for this week's walkthrough. I'd like to thank Jordan for joining us today. If you have any other questions on any of the derivations, obviously you can always ask us, but you can always take a look at the derivations that are in your textbook. There's a little bit more depth there. And so, until we see each other in the lab, I'm going to hypnotize you. Not impressive, mister. No.
Are we videoing this whole thing?
Yeah, why not?
Because it's not going to be part of the bloopers?
No, it's not going to be part of the bloopers.
Well, how would I know?
Because none of the stuff that we've done so far is very funny. And there it is.
This is why we can't do this.
All right. You offered. All right, so.
I did. I'll never finish paying for
y'all
it.
children are going to be fine. Just do the lab. You'll be fine.
Ooh.
All right.
You're getting very sleepy. Really, dude? I walked in here sleepy. But only people who knew me would get that joke.
Yeah, but everybody else walks in here is sleepy too, so that may actually play very well. When you arrive at lab, you'll find your setup.
I'm sorry.
So, here we go. Ready? Can I look at you? Straight face. We're good actors.